Hello, good evening, everyone. Hello.
Good evening, Mr. Samuel.
Yeah, good evening. Good evening. Okay.
Okay.
Yeah. Good evening.
Good evening, sir.
Yeah, good evening. Mary, good evening. And Okuchukwu, good evening. Good evening to you all. Enola Mary, are you there? Yes, sorry. Okay. So I'm trying to share my screen. I'm not. So okay, we have Mr. Nelson, we have Steve Uchoma, we have Mr. Sivinos, Gospel Easy, and then Gochuku. All right. So I believe you've all launched your Anaconda, right? Hello, have we?
Not yet, sir, but I will do that now.
All right, please let's launch the Anaconda. Yes, and then quick one, please. Did you practice over the weekend? Anyone?
Honestly, sir, no practice. I no get light since now. Now, just go charge the laptop, bring and come.
Yeah, sorry. And it's our country, eh? It is well our government. All right. All right. So this evening we will continue from where we stopped in the last class. So before I share my screen, I'll ask some few questions. Yes. So please, first of all, right? Do we have any question so far? Any question? Any comments? Hello.
Hello, sir.
Yes. So I said, do you have any questions so far?
From my side, no, sir.
All right. International, any question?
No, sir.
All right. Ochku, any question? God's will, Mary, any question? Praise, any question?
No, no
Not
question,
for
sir.
now. Not for now.
Yeah, thank you. So I'm sharing my screen. Please just give me maybe 2 seconds or so. I'll share my screen. Okay. So I'm sharing my screen right now. Right now, from the previous class, from the previous class we had, or let's say from last class, rather, we worked on a train test splits. Train test splits. So yeah, and before I begin today's class, I want each of us to tell me what you understand by this train test splits. What we tend to achieve using that training, testing, and splitting. So I'll start with Mr. Sivinos. Please go ahead. I believe we don't have any questions now. So I believe we understand what that function actually means. So Mr. Sivinos, please go ahead.
Sorry, sir, I didn't get your question. He said what, sir?
Okay, I said right. The last class we worked on training, testing, and splitting. Right.
Yes.
Yes, I said I want us to speak on it. What you understand by training, testing, and splitting, and then why do we even have to do the training and testing? So that's two questions. So
Okay.
please go ahead.
For one to come up with a model, you must train the model, and at the same time, after training the model, you
Please go ahead. I can hear you. Hello. 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 Okay. I think it's having bad network. Um, Goswin, please. Hello, Goswin.
Hello, sir.
Yeah. So please go ahead. Just tell me.
Okay. Um, from my understanding,
Yes.
we splitted one column from the others because that one column is the outcome column already, and we are
Okay.
trying to change this model so for us to get the outcome. So there's no point having this outcome column. So we assume that this outcome column does not exist for us to train our model and get and achieve our outcome by ourselves. So we trained the whole model. At the end, we now used we used 30% of the data set to test the data set that we've trained, the model that we've trained. We now use 30% to test it. Like you said, we can also use 20% to test, and we can also use 10% to test, but we use 30% of the model to test the model that we've trained.
Okay. Okay. Yeah. Yeah. Nice one. Nice one. Nice one. Okay. So let's have Mr. Nelson.
my phone went off.
Okay. Okay. Okay.
So I'm sorry, I'm in a vehicle, but I can just add this one quickly. You say that while selecting the items for testing, we will do it randomly. And while doing it randomly, we can do it randomly until up to 42 times before we now change the mode of the selection. That's much I can add because I'm in a vehicle. Once I reach home, I will connect again.
All right. All right. Thank you for that. Thank you for that. Next we have a Favor Olamo and Praise. Favor, please. Okay.
Okay.
Praise.
Good evening, sir. Good evening, sir. Can you hear
Yeah.
me?
Good evening. Yeah. Can you hear
Yes.
Favor? Good evening.
So test split. So a data set can be done either 80-20, 90-10, or 70-30, in which a part is trained, then the other part is tested. Then While doing that, we have to avoid overfitting and underfitting. So that is the logic entirely.
Yes, thank you. Okay. Yes, please go ahead.
Hello, sir. The data set is split into two. That is the tests and the training. So the training validation and the tests. So after we use the size that is maybe 0.2, 0.3 to determine the percentage that we go into each for the test and for the training. So the test is we use the test to actually know if what we trained actually works in the test validation.
Okay. Yes, that's very correct. That's very correct. I'm coming, please. Okay. So I'm sharing my screen. Oh, okay, so I'm sharing my screen now. Okay, sorry. Okay. So from last class, right, we worked on the training, testing, and splitting. And as we all have rightly said, we are doing the training, the testing, and the splitting, where we want to fit the model. So we are fitting the model to our trained data, so that data set, right, so that model will understand everything about the data set, and then we will now test the model based on how well that model fully understands the data set, and from there we now do what we call evaluation, whereby we have to evaluate the model, we check the accuracy of the model, and then we can now make maybe probably a new prediction to see, just to test the model. So let's say, for instance, now after we've run the whole code, right? We've done the cleaning, your inspection, your manipulation, visualization, right? You've already encoded the data into numeric values. Then you do your data training, splitting, and testing. Now, what next, right, is now to import the models. Yes, the models for machine learning. Now we have different, or let's say we have two categories of ML models. We have supervised learning. Now from here now we have what we call a decision tree, classifier. Okay, sorry. Let's say this now. This is divided into two. We have classification model. Okay, models, right? So we have decision tree classifier. We have naive Bayes, naive Bayes. We have random forest. What again? We have support vector machine, support vector machine. And these are different models for machine learning. We have decision tree, IBs, RFC. We have K nearest neighbor, K nearest neighbor. We have once again, we have logistic regression. We have cat boost classifier. We have SG boost as well. Then yeah, and then so many other ones as well too. Now coming down to the second part now. Let's see, this is the first one here. Let's put it as I. The second part here, we have two. We have regression models. We have the linear regression. We have a logistic. We have decision tree regressor. We have ridge model or ridge regressor. We have lasso. We have random forest regressor. Then now, so this is then this A here, A. Then B now. We have what we call the unsupervised learning. For this, we have K-means clustering. We have K-means clustering, and we have let me call it agglomeration model. Agglomeration clustering. Now, if you are to these three here, these are the models we have in machine learning. Though we have some other ones too, right? Now we have what we call supervised learning. We have either it can be regression or you are classifying. For example, now let's say this our file here, right? It has an outcome, and the outcome is binary. Means that it is either yes or no, 1 and 0, or 1, 2, 3. Those are binaries now. They are numbers. You are predicting based on classifying. You are classifying the outcome based on either yes or no, right? Or as the case may be. Okay. So moving down here now, we have these models here, right? That you can use for this kind of tasks. Okay. Now, let's say you are predicting or you are to build a model that can classify or predict maybe the patient malaria status, to predict some other things as well too. And you can use any of these models here, right? Now in a project, you can either use one model, you can use two models, you can use three models, as the case may be, right? Now, the reason why you use 2 or 3 models is to compare the accuracy. Now, each models we have here, right? Each of them work differently. Now, the way decision tree will learn, right, is not the same thing. It's not the same with a naive Bayes or random forest. Each of them learn differently. Now, for naive Bayes, right, they work with the law of probability. That is, if all things are this, then it should happen. Right? That is, now for this, right, we call it the probability of A is given that B had already occurred. Now it means that for any result or for any outcome you are predicting, that event had already occurred. That is why you are training a model with a historical data set, past data set, right? So they learn differently. And you work on it. You apply 2 or 3 models together, and then you select the best model. Now, it's the best model that you now wrap as either a fast API or as a Flask API too. Yes, or REST API, because we have different API which we use to wrap our model, right? Now, then, for instance, now let's say you're working with a data set, and then the focus is on a price prediction, right? That is when you apply a regressional model. Yes, because you're working on price. For instance, now let's say you want to build a model that can predict the price of mobile phones, for instance. Now because the outcomes there of price is not binary, right? They are called continuous variables, because we have different numbers. We have like maybe 5,000, 10,000, 15, 17 upward there, right? Now, because those numbers there, they are not binary, then you can't apply these models for that type of task. Now, you applied either linear regression, decision tree regressor, rich regressor, lasso, or RFC regressor. So we have other regressional models too, which we use in predicting price, predicting price. And also too, we have what we call also advice learning. Please, I'm coming. Sorry, please. Yeah. Now, coming down to this models here. Let's say for instance, right? You work in let's say in an e-commerce company, right? And then the goal is for you to segment your customers based on how they buy from you. Now we have a different, or let me say, we have a type of analysis in that for segmenting. We have what we call a customer preference analysis, and then price sensitivity analysis. What we call a customer preference, customers, right? Customers preference analysis, and then price, price sensitivity, sensitivity analysis. Now, for these 2 here, right, is that it means that you want to group your customers based on those that buy what they want to buy. For instance, now, right, let's say you as a consumer, you want to get a phone, right? Now the phone is let's say the phone is 1M, for instance now. 1 million naira. Now, and then you get to the place to get the phone, and they say that phone is now 1.2 million naira, right? Now, because you want to buy the phone, right, you pay for the phone. That is what we call a customer's preference. You are buying what you want to buy. Then we have those that, okay, maybe probably you have a 1M for, as the budget for the phone. Then you go there and say, the phone is what? The phone is 1.2. Now, because you have 1M with you, you now go for what? You go for a more cheaper phone that 1M can buy. Now, they call that price sensitivity analysis. That is the price that influence your buying decision. Yes. So these are different models to group your customers based on that. Or for instance, now let's say you work in the health sector, right? And then you want to group, or let's say there's a let's say there's a new virus now, for instance, now, a new virus in Nigeria, and they say, okay, you, our data scientist, we want you to have a clusters of where we have high, low, or medium, what's it called now? What's the word now? Medium, either, okay, medium places where that virus, right, has affected. Now it means that you are not predicting, you are trying to what? To classify, to group the areas based on based on how well or based on how they have been or sorry, based on how that virus, right, affected the community. Okay. So now in essence, I'm saying that these models we have here, they work differently, they learn differently, and they are for different, for different purposes. We are the ones for predicting an outcome. We have those to predict your price. We have the ones for segmenting, as the case may be. So for every task you are being given to work on, you have to first understand the problem behind it, the problem, and then you get the right data set, right, that gives the accurate answer to your problem. Okay, and then look out for the models which you want to use. You can decide to use 3 models or 2 models, and then you get the best model. Now, there's also an advanced model. We call it embedding. Yeah, embedding. Let's say, for instance, now let's assume we have or we use 3 models. We use decision tree, we use naive Bayes, or we use a RFC. Now, each of them will give you, right, will give you their own separate results. Good. Now, what next is you want to embed them together. You want to combine the learning, or let me say, you want to combine the accuracy of decision tree, naive Bayes, and then RFC together to become one model. That's what we call assembling. Yeah, assembling. And for that as well, we have different assembly methods. You can either back them, you can boost them, or you can vote them. Okay. So I believe I believe before we end the class, we would get to how you embed your models together, and also how to wrap the model as fast API, because you don't deploy your code. Now your code, let's say you have this code here, right? This code here. Now you don't you don't deploy all this whole code flow here. Now you wrap the whole code as a fast API, and that API is what you give to the devs guys, either the front-end engineer or the back-end engineer. Okay, then yeah. So without much, let us work on 2 or 3 models, and then we see how it works. Sorry. So please, join any question before I proceed. Any question? Any question?
Good evening, sir.
So please, can you copy this and paste it on the chat for us on the WhatsApp group chat?
All right. Sorry. Okay.
Thank you,
Hello,
sir.
sir.
Yeah. So let's import.
Good evening, sir. Sir, can you hear me? Sorry, can you hear me?
Yes, can you please go ahead?
Sir, I feel like you might still need to share more light on how to choose the model when we have a data set. I know that you talked about the difference between when we are predicting and when we are grouping, but still
Okay.
hasn't classify which model we should choose when we are given a data set. How do we choose? Is it compulsory that every time we are given a data set, we have to use more than 2 models before we choose?
Okay. Okay. Yes.
I feel like you still need to clarify more on that
Okay.
because
Yeah.
these are a lot of options.
Okay.
Yeah.
Exactly. Now, okay. Let me start by saying this now, right? It's not compulsory. Please, can you hear me?
Yes.
Now, it's not compulsory that you use 3 models, right? You can use just 1 model. You can use 2 models. You can use 3 models. You can use 5 models. Understand that? Now, the reason why I said you can use 3 models is that they learn differently. You understand? They learn differently, and yeah, they learn differently, and they have a different, different accuracy. Now, to your next question, how do you determine which model to use? Right? Yes.
We are not hearing you again, no, sir.
Yes. Sorry. Okay. Now, the question is how to determine which model, right, is best for you to use. Okay. Now, for these models here, we have decision tree, we have DTC, we have 9Bs, we have RFC models, then we have SVM model. Okay. Right. Now, these models here, they work for any data set. Okay. Also with this one too as well too. Now you can pick any of these ones here, right? You can work better on any data set. Or if you use card boosting or use edge boosting, now they'll give you a better accuracy compared to these models we have here, right? Now the reason is that the way these two works, they work by boosting what we call the weaker voters. I don't know if you understand. I don't know. Okay. Now, let me say this now. We have what we call a gradient boosting. Sorry, gradient boosting, right? The way they make their own, the way they, the way they are configured to learn, they learn similarly to a neural network, but not a neural network. So let's say, for instance, now you applied from here to here, right? Now, if your accuracy for DDC, let's say we have 89%. For these two, we have 87%, right? For these two, we have like 78%. Now, for this card boosting here, we have that 90%. Then here we have 91%. And also to we have what we call a light GBM, light GBM. Now this will give you a better accuracy In fact, the reason why we have AI or why we have deep learning, right, is that they want to improve the way these models learn. They want to be more practical than just theory. Because these models here we have here, right, they follow the law of mathematics and probability. That's why I said for this one here, right, naive Bayes, it follows the law that states that given the probability of A, sorry, it states that A is the probability of B, given that A had already occurred, right? Now, they all follow the law of probability, the law of mathematics, and all that. Now, coming down to deep learning, right? Deep learning, they mimic human being. Yes, thank you. Now, they mimic human being. They mimic the way our brain, right? Our brain learn, and they have neurons pass to them. Now, if you are to construct a deep learning model, you pass different neurons, different cells to it. Okay. Now, compared to just normal ML models, so you can decide to only work with decision tree for any data set. It works for you, right? Now, note that if you apply decision tree on this file we have here, and then let's say we have like 89% as we have it here. Now, you now applied the same decision tree to a different or to similar data set. Now, the result you have here, it can either increase or decrease. So there's no special way, right? Or no special technique to know which model will work best for a data set. You can try the same model for different data sets and you get different results. In fact, if we apply these same models we have here, this model here, decision tree, right, to this our own no data set here, we will all have different results. I can have either I have 8%, you have 81%, but we all get what a different result. We might not get the same result, and we work on the same data set too, but then we'll get a different result. So there's no let me say there's no particular method to know which model works best for data sets, right? But just know that you can use any of it. Now, if you are using a boosting model, you will tend to have a higher accuracy compared to normal model. So these three we have here, right? They are more of advanced model compared to these ones we have here. Is that clear now?
If that is the case, why can't we not just be using XGBoost for everything? At least to save us more time from learning others, if that was the case, if I may ask that.
Okay, yeah, that is that's very correct too, right? But then now, before this models, right, coming to be now, these models were the first model using them before this boosting now comes in this recent word now social. But then it was more of a decision tree, naive Bayes, SVM, and all that there. Before we now have all these boosting models.
Okay, sir.
Hello?
Okay, sir.
You get now?
Yes.
Okay. Is that all? Hello?
Yes. That's all for me.
All right. Okay, Mr. Sirinos, any question? Mr. Nelson, Ugochukwu,
No
God's
questions.
Please ask questions.
network has been going off and on. But not just happy today. And now my power bank, while I use the power machine, don't off.
You said what?
My network has been going up and on, so I
Yes,
just came
yes.
back and joined this one. So I just pray it will not go up again.
Okay.
Let me see if I can.
Pardon, it's okay. What of your Olamiri is not here. Okay. So please let's proceed. Now let's now import our models. Okay. Now for your question, Favor Uchoma. Yes, yes, we will. We will. Okay. So let's apply let's import just 3 models for tonight, 3 models. Okay, or 2 models rather. Let's import decision tree. That will be from sklearn dot tree import decision tree classifier. Then from sklearn dot let me put it dot naive underscore base import portion and okay. So this one we have here now, right? Sorry. This is for decision tree DTC. Why this for naive base? This is naive. Okay. Now I've imported my my libraries now for my models, right? Now note that I'm working with X-train, X-test, Y-train, Y-test, not DF anymore, right? Because because we've already split our DF into X and Y, and then we now have X train, X test, Y train, Y test. Okay. Now I said we are training the model, right, with our X train and Y train, right? So let's now call the okay, let me put the comments here. Let's call the TTC model as a function. That will be DTC equal to decision tree classifier as a function, right? Okay, good. Now let's fix or train the train set, the X train and the Y train to the model. So that will be DTC dot fit, right? Then what we have our X train, comma Y train. Then what is now? Okay. Now at this point here, right? At this point here, now the model has learned the pattern, everything about our X train and our what Y train. Okay. Now the reason why this thing here did not take time is because you're working with a very small data set. Let's assume that we're working with a maybe a very large one that range from 1 to like 10 million upward. Now, this guy here can take like up to 10 minutes before we have this green, sorry, this blue is what we have here, right? Okay. So now we have what we now have. Okay, we have our we've already fitted the X train and the Y train to the model, right? Okay. Let me comment here. we fit the model. We fit the model to the data set. Okay. Now let's not make a prediction now. Let's say this is spread equals to DTC dot predict. Then we'll pass our S test. Okay. Now this is spread. DTC spread. Let's put the first thing. Okay. Okay. Now let me explain this again, step by step again. From here, from this code you have here now, right? We imported the libraries for the model. So I import DTC and naive base, right? Now I call this library I have here, I call it here to become a function, right? And then save that function as this variable here called DTC. Okay. So it means that this word here, this word DTC, now saves or stores our model. So what next is now to fit the X train and the Y train to the model. So we come down here and say DTC dot fit, right? And then we pass our X train and our Y train to the model. Now at this point here, right, that model now fully understand everything about our data set, the X train and the Y train, right? Now, note that we have what we call we have X train, we have X test, we have Y train, we have what Y test. Now, the last class, right? I said we use the S test to test the model, right? Yes, to test the model. Okay. So here now, right? Now said GDC dot predict, and then we pass what we pass our S test here. Now note that what we use 80% for training, right? And then 20% for testing. Okay. Now it means that the model here understand everything about this training, this S training data set here, right? Or you can say that the model, right, only see what we have inside the training, the X train. Now the model did not know anything about the S test here. Is that clear? Hello? Hello?
Not clear.
Hello?
Not clear yet, sir.
Sir, come again. Sir.
Right. Let me come again, because this thing now must get right. Okay, so I'll start from this line 28 again. So I said wants to apply the model to our data sets. We are predicting using these two models we have here, decision tree and the naive base. These are just two models we have here. Okay, so the first model is a decision tree, DTC. So on in this line 28 here, I import it here as a library, right? Then I call it up in line 29 as a function, which is this here, as a function. So I save that function as this variable here called DTC here. Okay. Then what next now is now to fit in the X train and the Y train to our data set. So to the model, decision tree model. Good. Now note that we have what's it called now? We have a thank you. We have our X string to be 80%, right? And we have our what? Our S test, right? To what? To be 20%. Okay. Now, at this point here, the model only know everything about X train and Y train. The model did not see what we have inside what our S test here, right? Now we fit the model with our X train and with our X train and our Y train here, right? Now at this point here, that model now understand everything about the whole X train and Y train here. Now we're not saying that okay, this model uh, based on what you learn about this our X train and our Y train here. Now predict our S test, right? Now it means that, or let me say, we now pass what? We now pass this our S test here to the model, right? Now that model will now generate what? Will now generate another Y test. Is that clear? Hello.
So
Yes,
come
sir.
again.
I don't
Explain
understand
the
how
concept of the Y text and the
Y
Y train
test.
again.
Now, you know, we have X test here, not Y test now, S test now, right? This is S test. Note that, okay, let me say we have a X train here, X train, we have S test, right? We have Y train, we have Y test, okay? So it's on to be chat, okay? We have X train, we have X test, we have Y train, we have Y test, okay? So here now, right, we have used our X train, and Y train. Okay, let's say, right, this is already out already now. This is out already now. So we now have what? We have our S test and Y test left now, right? Now we now okay, we passed what? We passed the S test here to the model because the model has learned everything about the X train and the Y train here, right? What's it that this is done now already with now. Now this model here now predicts a new Y test or a new result, either yes or no, yes or no, yes or no, right? Now, okay, please, is that clear now? So we're having a new result here, right? For this our S test here. So what next now is now to evaluate the model to compare this new Y test here, right, with the initial Y test and see the accuracy. Okay, so let's now import a library for accuracy. That'll be from sklearn. From sklearn.metrics. Then we import accuracy underscore score. Okay. Now let's compare this our new Y test here, this new result here, that the model predicted here with the original Y test. So that will be accuracy, or let's call it DTC accuracy, let me underscore equal to accuracy underscore score, right? Then what? We pass our decision pred, DTC pred, comma, then the y test here. The y test times 100. We run this and then we come down here and print the accuracy score as 80%. Hello.
We can hear you.
Hello. All right. Yes. Any question? Or should I come again?
Yes, sir.
Question. Is the question?
So that multiply by 100. Why are we
Okay.
multiplying by 100?
Now, let's say the way it works is that it give you the result in decimal.
Okay.
Then you have to
Okay.
do times 100, to see it. That's how it works now.
Okay.
Okay. So let me come again. Let me explain this whole thing again, right? In fact, from beginning to the end, after your cleaning, your inspection, your EDA, your encoding, then what you now split the ODF into X and Y, right? The X and Y. Your Y will be your target variable, while your S will be your features, right? Then you split that X and Y into training and testing. So we now have X train, X test, Y train, Y test, right? So I said we have different models for different prediction. And I said each of them will give you a different result for your accuracy based on how based on how they learn, right? They learn differently, and each of them they have a formula, a formula they use to do them manually in mathematics. You understand? They all have their own different formulas they use. Okay, and that's why they're called a math model. Now you can see. Okay, let's see decision tree, decision tree, decision tree formula. Right, sit here. See, they have what they have their own, they have their own formula. Okay, that's mathematics. Okay, so here now, right? I said after after you have we don't have our X train, our X test, Y train, and the Y test, right? Then you import the library for your model. Now we imported decision tree and then naive Bayes. Okay. Now we call decision tree as a function here, and then we save it as what? Our DDC as a variable, right? Now what next is now to fit the X train and the Y train to the model. Your X train is your features, while your Y train is that is our target, right? And they are both of the same shape in terms of the rows, right? I think this should be like nine columns and maybe 2 something rows, right? And then for your target, it's always one rule, just the target rule. Now, at this point here, the model has already learned everything about the old data set here, the old S train and Y train here. And I said that model did not see anything we have on that our S test here, right? So then on this line 31 here, we now said, okay, what we what the model has learned in line 30, let's now predict the S test here, right? And then we save this here as what? This is pred as a variable, right? And then what? We printed the first 10. You can print the first 30, right? It still works too. The first 30, okay. Then I said the model predicts a new Y test, a new result. Now you can say, okay, or let's say we built the model already, and then you are you are inserting new customers record. Then that model is not giving you a different prediction. This is just how it works too as well too. Now the model is seeing this our S test here, right, as a new data set without an outcome. So the model gave us, or let me say, the model predicted the outcome for this our S test here, and this is what we have it here now as the outcome here. So I said, what next, right, is now to evaluate the model. That is, we are comparing the new Y test, the new results, right, with the actual Y test on your data sets, which we did here in line 38 here. Now, in this part here, right, we imported the metrics called what's it called now? Accuracy score, to evaluate the accuracy of the model. Now we have other metrics too, aside this. Not remember, I said for this year, this list here, we have different metrics to evaluate all this year. We have different metrics to evaluate this as well too, and then this as well too. Now let me just give a list of those metrics. Now let's say for number one, supervised learning, or let me say for classification models, you can use what we call accuracy score, and also score. We can use confusion matrix, confusion underscore matrix. We can use classification reports, right? You can use your recall. You can use precision. You can use F1 score. Sorry, F1 score. For your regression, right? We have what we call a mean square error, mean squared error. What we call a mean absolute error. We have your R squared. Then now for unsupervised learning, unsupervised learning, right? We have what we call a silhouette score. Okay. So these are different different metrics to evaluate your models. Okay. So let me copy this now and paste it in this chart here.
No, sir, please paste it in the WhatsApp chat.
Okay.
My WhatsApp is not linked to my phone, Abi computer.
All right. Okay. Yeah. Okay. So let's now use the second model, which is a naive base. So that will be, let's call it base. So naive as the variable equals to Gaussian NB. This spelling again. Are we on the NB? Okay. So we have naive dot fit, right? Then we'll fit our S train. The same process. S train. Sorry for saying. S train, Y train. Then we have naive bread equal to naive dot predict S test. Okay, so you can say naive bread. You can print the first 10 as well. First 10 for the model, right? Then you do your accuracy. So naive underscore accuracy equal to accuracy underscore score, right? So you pass your naive bread, comma, Y test, then times 100, right? And you print your naive underscore what accuracy 3%. Okay. Now, what's the name first now? Favor Lomo. Now, see the results here we have here, right? We applied these two models here. We use the tree and the naive base. Now, this one, right, give us a more better result now, 80% compared to this model we have here now, naive base. Now, it means now we can also apply these two models now, right, on a different data set. And then this one we have here will give us a good accuracy compared to the tree. So that's basically how it works. Is there any question?
So, sir, are you saying that the passing grade for a model to be accepted now is 80%?
We can have 80, we can have 90, 95, but we must not have 100%.
Yeah, I'm saying for us to say, okay, the model to a large extent understands the data, the
Yes,
passing grade
yes,
has to be 80%.
yes, 80 upward, yeah, 80 upward. 80
Yes.
upward.
And what if you have below 80?
Then you can try
You
the
use another
models.
model.
You can try the models too and see the one that works better. But that's still right. We now embed. Sorry, is it embed? Yeah, you assemble addition tree and this together to give you a more a more better result.
Okay, you join two models together to give you a better result.
Yes. They call it embedding.
Okay.
Or you back them or you stack them. They work differently too. No, please give me like just 3 minutes, please. Let me bring one gem, please. Hello, did you hear me?
Abeg,
Yes,
this
sir.
okay.
Yes, sir. Yeah, yeah.
Yeah, just 3 minutes.
Everything will go on today. I don't know. Anything will come. Kai. My network keep on logging me out. Before I go connect, I have to go offline mode, come back, it go connect. Small time, it go off me again.
We are not missing anything. We are not even catching up like that. And
Kai.
still,
All this code now, I don't have it. I don't know from the up, and I just those supervised and unsupervised listing when you list there, that was where I stopped. This testing what you do here, I didn't do any. I don't know how it started. I don't know how it gets here. Kai, this kind of thing diverts me. And my laptop, people are saying now 10 minutes is meant to go off. That
my
means say
own,
this
my own are 5. I don't know why they
today
took light. That normally has light every time.
today class no be for me. I pray may they just post the video. Make I go learn this thing back there. I don't verse.
Absolutely.
Make I
Hey,
come online. No need today here. I just dey make myself the verse more.
it's better you stay online.
If I go online, laptop there 12%. Where it go off at any time.
Use your phone and follow up now. Just be in the class and
This
follow up what's happening.
class of today is not even about copying. It's about understanding what is happening.
My
That's
phone
what
self don't off. My phone power bank don't off. So it remain like 6-7% to go off.
go and buy new power bank.
Honestly, I have to. By next week or thereabout, I have to go and buy a new power bank.
Just Christ of Nazareth.
I have
Why
to.
am I doing 80%? Why the one here is giving 63? What did I do?
So if you don't run your own, you don't try your own. Me, I no data to know how it take. Nah, I just the first.
Yeah.
I beg at the end, just save the file, send to me, make I run am this night before I go see video. Then we don't
Okay.
maybe this night. If any day I charge my laptop, I go do them before they go post the class recording. Man, just run them. So I will listen to the class recording. I go grab small.
No wahala.
Just at the end, save the file, send to me either by WhatsApp or any means.
Hello.
Yes, sir.
Hello. Please can you hear me?
Yes, sir.
Okay. Yes. So we have we now have this model here now. Now, if you are to what's it called now? If you are to
So I have a question.
please go ahead.
So this is your outcome for this last model that we used, that you're having 63%. Does it mean you're not meant to use that model, or you submit the both models together? You
Okay.
embed it like you said.
No. Okay. Now let me okay. You know here right now we have this these two models here, right, with their different results. Okay. Now we don't save we won't save all this code here. You get that now? Now we only save the model, right? We save this, we are picking just one model. So this one here now, decision tree, and this guy here now, my base, right, that has 63%. If you are to deploy any model, you are deploying this one that has a better accuracy. You get now? Now, I said we can also assemble them together. That is, we are adding or let me say we are combining this decision tree model with this model here to become one model, right? Now, if we should assemble or combine this one here to this one here, we would have, let's say we have like around 93% upward. You get now? So now is that model that will now would deploy the model. You understand? Now, before you deploy the model, because this ML, you can or let me say, you first save the model. You export it as a pickle file. Then you wrap it as a fast API. Then you deploy it. Okay, so that's how it works. You are picking the best model, not the two models. The best model. Even if you assemble them together, you are picking the one. You are picking the assembled model, which will just one result, give you just one result. So that's how it works.
Hello, sir.
Sir.
Hello, sir. Can you hear me?
Yes. Please go ahead.
I don't know why after doing this last solving, my own, I'm getting 80%
Question.
instead of 63% you got. Does it
Okay,
mean
very
different
good.
people can get different answers or what?
Yes, I said, I said, if we use the same model, the same data set, we have a different result. You get that? Now, it also work with your system configuration as well too.
Okay, it also works with system configuration. You said it also works with my system configuration.
Yes. Yes. You don't use yes. In fact, we have some system that we can't use it. We can't do this code on them. They can crash. And the reason why I'm using a very small data set is because I don't want to keep our system hanging. This is need most times they need a more heavy laptop to give you a good accuracy. So you will definitely get a different result based off the listing of the model.
Okay.
Hello, please can you hear me?
Yes, sir.
All right.
So I have a question.
Yes, please go ahead.
So I just want to be sure, from like 46, the array that is there, is that the value for the white, is it what training? Like the status column? Like now, the result.
This is okay. Now we have what's called now our S test and Y test here, right?
Yes.
Now we pass the S test here to this model here, right? Now the model predicted a new result for us. Is that clear now?
Okay. Yes. This meeting is being recorded.
Hello? Hey there, Mary. Yes. That model, I can't hear you. Hello, I can't hear you again. No. Hello?
Yes, sir.
Okay. Now, yeah. I can't hear you at all. I can't hear you. I don't usually me. I can't hear you. Hello? Hello, I can't hear you.
Sir. Can anyone hear me?
Yes. Please go ahead now. Okay. Yes. So
yes, sir. So I'm with you, sir.
Okay. Yes. So I said
that.
Okay,
so you were explaining the array part.
Yes. So I said what we have here, what we have here now, this one here,
yes,
is the new prediction that the model predicted using our S test here. So that's why we came here right, in line 47, and compared the prediction with our original white test, and we get this accuracy.
Okay.
Yes.
So the 10 is saying the first 10 data set of the CSV file.
Of the S test here. Now this S test here is like this now. Okay, let me see S test dot ed right. Are you there now? Let me watch my screen.
Yes, sir.
Okay.
I can see your
now
screen.
let's say first 10 the first 10 here too, right? Now for 249, right? The model was
Yes, sir.
stated 1 as the outcome, right? Now meaning that one is yes, Abi, because n is what now?
Yes.
N is 0, y is 1,
No.
right?
Yes. Yes, sir.
So now is that, or let's say the model, right, is now predicting the outcome for this our white test here. So it's seeing this, so it's seeing this our S test here as a new data set. You get now?
Okay.
So
Yes,
yes, this 1 we have here, they are the outcome for the first 10 we have here. Because even if we say, okay, yes, we print the first 20, right? First 20.
Okay.
See, then here too, the first 20, right? So now when was saying that for this 249, 25, 256, 264 here, right? They are all yes or true. You understand? So then coming down to line 47 here, we now compared this new result here, this our new output here with the original test, and then we have it as 63%.
Okay.
Yes, please.
Hello, sir. I have a question.
Okay.
Hello. Hello.
Hello. Yes,
Can
please
you
go
hear
ahead,
me?
sir. Yes, please go ahead.
My question is, where is the original white test coming from? Because I've been hearing of original white test. Maybe I missed something in the last class or something.
Yes. We have what? You have this see line 19 now, right?
Okay.
S train, S test, Y train, Y test, right?
Mm-hmm.
We split our ODF into
Okay.
X and then into X train, X test, Y train, Y test. You get now, sir?
Okay.
Yes. So we train the model, we train the model with only X train and Y train, right?
Mm-hmm.
Okay. Then now based off what that model has learned from the X train and the on the Y train, we now use
Okay.
the X to test the model. Then that
We use
model
the S test to test it.
yes. Then that model,
Okay.
right, gives us what? A new prediction. You understand?
Okay.
They now compare the prediction of that the new S test with the actual white test on the table.
White test on the table.
Like
Where is the white test on the table?
No, we have listen now. We have the S train here. We have S train. We have S test. We have white train. We have white test here already. These are like different data sets. You understand?
Okay.
Yes.
So, what was the data set? Was it taken from this original data set that I'm seeing now?
Yes.
So the S train now, Abi, the S train, does it comprise of all the columns in that S data set,
Yes, except the status here, the outcome.
except the outcome?
Yes. Now
So
that
when
outcome
you are
white train.
doing S train and S test, you are doing all of them joined together at the same time.
Come again.
Like when you are doing S train and Y test, S train, when you are doing anything X train, is you are doing it together, like you are doing the gender, married, education, self-employed, all of them combined together is what is being done run at the same time
Yes. Well, S train.
for you to get the Y, which is the status.
Which one?
Hello,
Hello.
can you hear
Please,
me?
please come again. Come again.
Okay, now I'm seeing. Okay, just drop down your screen a little. Let's go to that first data set above this one. Okay, so what you are comparing it with, is it this status, this 01111, this thing? Is it what you are?
Yes.
Is it the
Yes.
original one?
Yes. Original one. Yes.
Okay, that's what I'm trying to find out. Where the
Yes.
Y test was, the original one was brought from. So it's from the 0111 now that we are seeing. After the
Yes.
conduction of the test, we go and check how good it matches this one. Is it what we are doing?
Exactly.
Okay, no
Okay,
problem.
sir. Sir, can you scroll up a bit where we had that shape, the shape of the X train, X test, and yes. Sir, you mentioned something the other time. You said that the shape should be the same. I don't know whether it was X test. Okay, I think it was X train, Y train. But from line 22, the shape is showing 218, comma. It's not showing anything. Same thing
Which one?
for 55. Okay, up.
Yeah.
No. You were there initially. Okay. Yes, this place. Line
Okay.
18, 273, comma. It's not showing the other number. Line 22, 218, comma. It's not showing. Same thing for line 23. Why is it like
Yeah.
that?
Okay. Now the Y shape, the Y, right? Y is just the out of status. You understand it? Now it's only showing
Okay.
you. Yes, it's only showing you the count of rows. You get now. This one here
Okay.
is showing you the rows and the column.
Okay.
Yes, exactly. So that's why I mean it's just a 273 comma.
Okay.
Yes, please.
Okay, sir.
Is that one?
Another
Yes,
question is
sir.
this, sir. Is it when you ask for the S test, you get Y test as the answer? I don't understand.
Come again.
Is it when you ask for the S test? Because from what I'm seeing, if you drop down to the last, let me point out what I'm trying to ask. Okay, wait. Okay, here where you asked, okay, predict S test. For you to predict knife.predict S test. To predict S test, does it mean that is the Y test that is going to come out? This array
Now,
that came out, is it pertaining to Y or is it an outcome of X?
this array we have here
Yes, sir.
is okay. This result we have here, right, is a new prediction based on what the model is predicting as the S test. You
As
get
the
that?
S test. Okay.
As the S test. You know that we pass the S test to the model, right? Now that
Okay.
model is predicting based on what it has learned from the X string.
Okay.
Is that clear now?
Yes.
Okay. Yes.
So it's predicting what is it has learned from S string, but now
Yes.
it's being used to conduct a fit. Will I say how it fits to Y test? Is
Exactly.
it what is done
Let's use
below? the accuracy score.
Yes. Accuracy score.
Accuracy score is now being matched to Y test to
No.
find how it fits it or what.
Yes, it's comparing the prediction results with the Y test.
Okay, the prediction result of the S test.
Yes.
The Y test that is already known. That is the Y test in the column.
Yes, in the column. Yes, in the column.
Okay, it's matching it to know. Okay, now I'm getting it better.
Yes, sir.
Okay, sir.
Yeah.
Okay.
Okay. Yeah.
It's okay, sir. I'm okay now.
So please, next topic. I can't hear you, Miriam. Come again, please.
We see that the output of line 51 is the Y test of the X test.
Come again. Hello. I can't hear you. I can't hear you. Hello, I can't hear you at all. I can't hear you.
Sir.
Yes, please. Hello. Hello, Mary. I can't hear you. Hello. It's 60 here.
Hello, sir.
Okay, I can hear you.
Okay. So I was saying that for this line 51, can we say that since line 45 is X test, that means we are testing the first 20 of our X test. So
yes.
Can we say that line 51 is now the Y test of the X test in line 45?
That's your.
That's the Y.
Sir?
Please come
I
again.
didn't hear you, sir.
Please come
Okay.
again.
Okay. So I said that
Okay.
since line 51 is the output of line 45, and line 45 is X test, can we say that line 51 is the Y test of line 45?
No.
Yes, special. Yes.
Okay.
Yes. See, now,
Okay.
let me say, let's say, for instance, now, right? We've used the model already.
Yes, sir.
Abi, at line 45,
Yes, sir.
line 44, right? It's working
Yes,
already
sir.
now in our system at 44. Then we now have a new customer. Yeah? They are
Yes,
come
sir.
to get you get now. We now what we collected their information, the gender, their gender, the marriage, all those stuff here, right? And then we
Yes,
put
sir.
on the computer, and then that model, right, predicted one that is yes, right? Now that model is predicting based on a different data set. Now this model, this model here, right, is seeing this our S test as a different data set. Now, it's giving us
Okay.
this result we have here, based on what it has learned from the X train and the Y train.
Okay.
Okay, is that clear now? See, no way,
Yes,
like
sir.
this now. Now, let's say,
Yes, sir.
now, let's say you're in a school, you're in a school, right? In a school, you have, you have gone through the,
Yes, sir.
through the training process. You understand? Then your lecturer like
Sir.
gives you a test to do, right? Eh?
Yes, sir.
Now, you will give the right answer, right? But based
Yes,
on,
sir.
based on what you've learned now in class.
Yes, sir.
Yes. So
Okay.
now, let's now assume that this is your what? This is your own answer now. Exactly now.
Yes, sir.
Yes. Then the lecturer now compares your answer with the marking, with the marking guide, and give you your results accuracy. Is that clear?
Okay. Yes, sir.
Yes. Yes. So
Thank you.
please, yes, please, let's stop here for today.
Sir, about the matter that I raised last class of the videos, the recorded video,
Okay.
because so I'm still at the, of course I understand what you are saying, but come to the coding, I'm still at the back and I'm trying to meet up as much as possible. So
Yes, I told Mr. Martins about it. So he said that what's it called, that they would try to be dropping this thing, the recording, at least 2 days after the class.
okay, thank you very much, sir.
Yeah. All right. Thank you. Good night, please.
Thank you, sir.
Yeah.
Okay.
Hey, God. Okay. Sir, please, can you send us the PDF or HTML of the work we did today? Hello,
All right.
sir.
All right. All right. Hello.
Thank you, sir.
All right. Hey. Sorry, I'm serious. Let me log out.
Chioma, ka ihe i buru nnọọ bịa kpọrọkwa ọkụ anyị ebe a na. Pụchakwa anyị ebe a.